Okay, so I'm just going to go a little bit backwards towards the class that I took in the last session because I just want to do a quick revision and then come back to what I want to teach today. Okay, so what we were doing in the last class was about the internet, right? We had started with what is computer networks, then we had talked about what are the different parts of the internet, and then we had gone towards access networks. So today we will start with access networks, but before that, let me just review what we had studied in the last class, right? So here, as you can see, it is given that I mean, a nuts and bolts view of the internet. So it is nothing but what are the basic components of internet. We have already studied about this, like we have protocols, we have internet standards. What I want you to see is the diagram here. Okay, so if you see the diagram here, um, if you look at the mobile network that is here, so here you can see that we have cellular communication going on. So as I had mentioned earlier, that this is the base station and there is cellular communication going on between the base station and the mobile phones, and as well as if you have autonomous vehicles, then they can also communicate with the help of cellular network. Okay, so that is why 4G is put here. Okay, then you have the home network. So I had in the last class I had told how the home network works, what is exactly the home network. Okay, so what is being shown here in this diagram is that you have different classifications of networks. You have mobile networks, home networks, enterprise or institutional networks, but they are also communicating with each other. So here you can see that there is a device which was under the mobile network, working under the mobile network, and there is another device which is working in the home network, but they are also communicating with each other. Okay, and the name of the application in here is Skype. So you can actually communicate within these different networks too. Then comes the enterprise network. So here basically the different standards, different protocols, different technologies have been mentioned. So 4G is one here, Skype is one kind of application, HTTP is a protocol that is being used in order to, while you are having a communication from a client to a server system. Okay, then Ethernet is a protocol, Wi-Fi is a standard. Okay, so and then yes, of course we had talked about TCP. So TCP is also a kind of protocol that we use when we are trying to communicate. Okay, then IP is another protocol too, as you can see here in the core network that is being used. Okay, now in this course you will see exactly what are these different protocols, when are they used. So you will learn about IP, you will learn about HTTP, Ethernet, TCP, and even you will get some ideas about Skype, 4G, Wi-Fi, etc. Okay, so this is the diagram that I wanted to show you, that how the different protocols are, or where are the different protocols working in this basic overview of the internet. Okay, so let me go back to the access networks which we were talking about. Okay, if you have any questions you can ask, otherwise I'll go to the access networks. So this was done. Okay, so now we are going to look at the access networks. So when we are talking about access networks, we first need to know about what are the components which we are trying to get access with. Okay, so these are the basic end systems or hosts which are basically at the edge of the network, and these are basically they will either be clients or servers depending upon what is the application that they are serving. Okay, you can also have data centers as at the edge, right? So at the edge we have devices which, as I have told in the last class, at the edge we have devices which have or which are responsible for having applications or for running applications and serving the users. Okay, so they can act as clients depending upon whether they are the ones which are requesting the service. They can act as servers depending upon whether they are actually helping to serve the request that has been given out by the user. Okay, so here you have different hosts or end systems which are basically at the edge of the network. So they are basically the marked ones here. Now, how will these devices communicate with each other? They need some way to access another uh, part of the internet, right? So, which part of the internet they need to access? They need to access the edge router. How will they access? With the help of some kind of communication standard. Okay, so what we need is some kind of medium through which the signal that the end system wants to send the data through. Okay, so it can be a wired link or it can be a wireless link. Okay, so as you can see here, if you can see my mouse, if you can see here at the mobile network, you can see that these devices are being wirelessly connected to this base station. Okay, and the base station is again connected to the edge router through a wired manner. Okay, so whatever data is being sent by these edge systems, whether it's a mobile phone, whether it's a laptop, whether it's a car, whatever the device may be, they will communicate their data with the base station through a wireless manner, through the wireless communication link. Once that is done, this base station will be responsible for sending the information to the edge router, and that is happening via a wired link. So similarly, you can see that in the home network, if you are having a Wi-Fi connection, then how this is working out. And then if you have your enterprise network or the institutional network, then also there is a, see, as I have told you that there will be a set of routers which will actually help to get all the data of the entire institute or the company or the enterprise and forward it to the ISPs, that is either the local ISP or the global ISP. Now, as I was talking about the local and global ISP, I have already mentioned in the last class too that these are basically part of the network core. Okay, they are the ones, a group of all these routers which are there in the backend, switches and routers which are there. So these will form the core of the internet or the backbone of the internet. Okay, so there are three kinds of networks that we have got to know from the last class too, and now also we are just discussing a little bit with a this is a different kind of a diagram here than what I had given out in the last class. So you have residential access network, that is the home network I was talking about. You have institutional access network. You can also call it as enterprise network, which is used in general in companies, institutes, schools, etc. And then you have mobile access networks. Okay, so here in our mobile access networks, we will have cellular networks, which is basically your how your mobile phones communicate with each other. That is your 4G, 5G, etc. And then you have Wi-Fi also under this. Okay, so we had left at digital subscriber line or DSL, which is a kind of an access network which will help your system to communicate with the internet. Okay, so as we had discussed in the last class, so the DSL modem, okay, that is the one which helps to send out the digital, the data, the signal that is coming from the system, the computer system, okay, that's in a digital format, right? That will be probably a pulse format, okay? But when it comes from the modem and it has to go through the wires along with the telephone line, then it has to be a analog signal, right? So in that case, what we do is this DSL modem is the one that helps for this conversion, right? So we do have a splitter in between that will basically determine that which signal to send to which part. So suppose you have a DSL line in your house, it will not be like at a time when there is somebody who's using the computer, the other person will not be able to use the phone. Okay, this used to happen earlier when early 90s. This was the thing that used to happen. You know, you had simple modem at house. At that time, broadband was not that much common in households. So there were simply modems that were used in the computer systems. So you could take from the telephone line itself, in a similar manner, you could do that. But in that case, what would happen is that when you are using the telephone line, you cannot use the computer system or cannot use internet at the, in your house. Whereas when you are using internet, then you cannot use the telephone line. So there was no splitter at that time. Okay, the concept of splitter came later on when this was became a little inconvenient for the users, that when I'm trying to browse the internet, I will not be able to talk on the phone, or somebody else in my family will not be able to talk on the phone. Okay, so because of this issue, splitter came into picture, and then after that, it was taken a little more further towards digital subscriber line or DSL connection. Okay, so the splitter is the one that determines that what is the kind of signal that is coming out. And that needs to, basically, if there is an input at the house, if there is the input that is coming from here, the splitter is the one that determines whether this input signal goes towards this, or the input signal goes towards the DSL modem and the system. Now, if we are talking from the point of view that when I send a signal from the system at home towards the internet, if I am trying to browse something. So in that case, what would happen is the signal, now it is going out from here and goes to this DSL access multiplexer. Okay, so this multiplexer will be responsible for again sending the information or forwarding the information to its respective network. That is, if it is a voice signal, in that case, this DSLAM will be responsible for forwarding the voice signal to a telephone network, corresponding telephone network. That is, if you are talking on somebody, the voice signal will be sent towards the receiving end of that. Okay, whereas if it is a digital signal, that is, if it is related to the internet, in that case, that signal will be transferred over to the local ISP. Okay, so here the ISP is given out with the symbol of the router. So these are basically routers. Okay, this is the symbol of routers. They are connected with each other. Okay. Now, the DSL line or the broadband connection. So this uses existing telephone line to the central office. Okay, this DSLAM. And as I have already mentioned, that data goes to the ISP and voice goes to the telephone network. So the transmission rate, as we had discussed in the last class, so the transmission rate that is obtained in downstream, that is basically 24 to 52 Mbps. Okay, and upstream transmission rate, we can get up to 3.5 to 16 Mbps. Okay, now let's go into uh, some other kinds of home networks. So what happens in home network? You can access the internet via either in a wireless manner or in a wired manner through LAN cables, okay, or your broadband connection. All right. So once this happens, you have the modem, which is basically responsible for converting the signals, and then the signal is sent to the central office. Okay, from where it will be transferred to the corresponding ISP. Yeah. So I've already mentioned that this will be the modem, and this is the modem, and this is the router, which will also be responsible for providing the power firewall. And it's written as NAT here. NAT is network address translation. You will read about this in the next classes. Okay, and you can also communicate via wired connection, as I mentioned. So we call it, in local language we call it as LAN connection, but it is actually the Ethernet connections. Okay, so why it is called that, and why it is called as why is Ethernet called as LAN, that also we will read about in the class. This is a wireless access point. Okay, this was already told to you in the last class. And yes, if you guys would notice, when you go to buy some wireless access point, you would generally tell the person that give me a router. Okay, give me a wireless router. Because why is it called? Because in general, router is a different thing than a wireless access point, and a cable is also a different thing. Okay, so as you can see, DSL modem is a separate entity, router is a separate entity, and access point is a separate entity. Okay, but in order to reduce the amount of hardware that is required, these three are combined together in a single box, and they can, and in that case, we call it as a Wi-Fi router. Okay, that you generally buy from shops and then use it at your house. Okay, so that is basically containing these three things. Okay. Now, there's another way of communication, right? So that is, some of you, as you mentioned in the last class, that some of you had broadband connection. Now, there is another way of getting internet, and that is via cable connection. Okay, so there are many places where what happens is that the TV cable connection is used to give internet connection too. Okay, in this slide, we are going to see that how do we get cable-based internet access. All right, so what we have, so same concept goes here too, like what we used in the DSL1. So you have a modem here, a cable modem, and you have a splitter. Okay, so the works of these two are same as what was happening in the DSL part, except that here the kind of signal is the kind that needs to be checked is whether it's a digital signal or whether it's a TV signal, right? So that's what is going to happen here. Now, what is the difference between this and the previous DSL communication? So in DSL communication, from one house, if the data is going, it will directly go to the DSLAM or the central office. Okay, yeah, it will directly go to the DSLAM or the central office. But here, what's happening is that this main cable, okay, this main cable line, there are many houses that will take the connection from there. Okay, so many houses are basically connected to this particular main connection or main line. Okay, and then that information now goes to the cable modem termination system. Okay, so from here it will be separated as to whether it will go to the ISP or whether it is just going to the central office, where you will get the other information, the cable office basically. All right, from there all the signals are going to come back here. Now, what is the issue? The issue is that here data is also getting transmitted, and the TV signals are also getting transmitted, but they are at, of course, at different frequencies. Okay, so signals at different frequencies are sharing the same cable network. Okay, so that is a challenge here. So how do we use signals? How do we send signals at different frequencies? So you have different channels, and at which you can send your signals at different frequencies, as you can see here. Okay. So how do we use that? We use frequency division multiplexing, where different channels transmit at different frequency bands. Okay. Um, I hope that you have the basic ideas of frequency division multiplexing, etc. You might have studied this in your digital classes, right? Digital communication courses. Have you done that courses? Yeah, this is a question. I would need an answer for this one.
No,
Are you
ma'am.
aware of these? But you have not done any kind of digital communication courses, all of you?
There was a digital design course, ma'am, but not specific to communication. So,
Yeah, of course. It wouldn't be specific to communication, but in that one, you must have studied about, these things, signals, analog and digital signals, pulse coding, frequency division, multiplexing, etc.
I'm like
uh,
digital
Some
design
of
is
the things,
mostly of
ma'am, like
components.
multiplexing. uh,
Yeah, so see, you will need the basic things, multiplexing, demultiplexing, as you have said, you know that, and frequency division, time division, multiplexing, space division, multiplexing. I think that should be there in the
Ma'am, we
syllabus.
haven't really learned them in the context of networks. It was multiplexing was just introduced as multiple wires on this, like multiple transmissions on the same wire. We haven't really studied all of this in the digital design course.
Okay. See, um, what exactly is happening here is the same thing that you have learned in your digital design course. What happens in that is that a signal is going to transmit from one point to another, how you are transmitting the signal. Same thing is happening here. So here is a wire, this is the wire, just the signal is getting transmitted. How it is getting transmitted? So you have different channels where the channels will transmit signals at different frequencies. That is how the FDM concept is being used here. Okay, so since I just got to know about this, I will explain accordingly. Okay, from now onwards. All right. So this is the main cable that I was talking about when I was talking about cable-based access. So this is called as the HFC, or the hybrid fiber coax cable, a coaxial cable. Okay. So what are coaxial cables, etc.? That we will study a little bit, a few slides further down. But first, let us see that what is this hybrid coaxial cable going to provide us. Okay. So this coaxial cable is going to provide 40 to 1.2 Gbps of transmission rate. Okay, in the downstream, and it will provide 30 to 100 megabits per second of transmission rate in the upstream. Okay, upstream as in from your system to the ISP. Okay, that's uplink communication, and vice versa is the downlink communication or downstream communication. Okay, now what is the problem in this scenario? Okay, so as I was mentioning, right, there is a single cable that is that is being accessed by several houses. Okay, so that will create a security issue in this case, and also if there is some house that is basically trying to use a lot of data at the same time, so in that case the sharing amongst different components which are basically sharing the same link here, that becomes difficult. Okay, so a fair share among all the houses, among all the um, components which are basically using the same main connection, that will become difficult in that case. Okay, now let's get to wireless access network. So in wireless access network, so as I was mentioning you, that in general the wireless access is uh, provided with the help of access points. Okay, so the access point is the device that helps your device to communicate with the internet. It acts basically like a gateway. Okay, So WLAN or wireless local area network is basically the concept with which you try to access devices in a wireless manner. Okay, so what does it provide? It provides communication within around 100 feet of where the access point is. So if you have an access point at your place, so within around 100 feet of distance, you will get the communication with your device. Okay, so there are certain standards that are followed in WLAN. So basically the Wi-Fi standards. So they can be either 802.11b or G or N. Okay, so these are basically different Wi-Fi standards. They vary as per the transmission rate that they provide. So as you see here, the transmission rates are different that are provided by these standards. Some are providing 11, one is providing 54, another is providing 450 Mbps of transmission rate. Okay. Now, the one that we have studied right now is WLAN, that is for a shorter area, right? A smaller area. What we are going to look at now is for a very large area, right? Like for cities, for towns, for villages, etc. That kind of communication is known as wide area cellular access network. Okay, so basically it is how your cellular network is being provided to you. Okay, so what do we have? We have a base station nearby. You know what is a base station? We generally in local terms we call it as cell towers, right? Cellular towers. So that is basically a cellular base station that is acting as a gateway for all the communication that is happening with mobile phones or any device that supports cellular communication within its transmission range. Okay, and what is the transmission range of this communication? So if there's a base station here, the range that it would provide is around 10 kilometers. Okay, so within 10 kilometer of area, um, 10-kilometer radius, within 10-kilometer radius, um, whatever cellular device is there, that device will be supported by this particular base station. Okay, it provides around 10s of Mbps of data rate. Okay, it depends on, so why it is given like this a little vague, around 10s of Mbps, because this transmission rate that is obtained is dependent upon many factors, one of which is the distance of the device from the base station. Okay, that is, if your device is nearer to the base station, then you get a good data rate. If it is very far away from the base station, then you get a lower data rate. Okay, why that happens and all, um, that is again, it's part of wireless networks course. I would love to teach that if I get some time apart from whatever you have in your actual course. Okay. Anyways, let's just move forward. So currently what you have or what I have in my phone is basically 4G, because in our country we are having a stable 4G connection until now. 5G is coming up in our country. Some providers have started to sell out devices which support 5G, but the full infrastructure, full layout of 5G, it is yet to come in our country. Okay. All right. Now let's get to enterprise networks, or what we can call as institutional networks. Okay, so let me give you an example of our institute itself. So as I had mentioned that, in your hostels you have your rooms where from where you can actually um, connect an access point and then use the Wi-Fi, or you can simply connect an internet cable and then use that cable for accessing the internet. Okay, but there are several of you in the hostels, and if all that data had to be sent to the ISP outside, and then that communication had to be done, then it would be a lot of load for the ISP. Okay, that is the internet service provider. So suppose BSNL is our internet service provider. So in that case, the local service provider, the local ISP or the local router, that is basically the gateway for our institute's data, that will be under too much load. Okay, and of course, when you are having a large number of users using the internet, then the question of delay will also come, because if so many people are using the same one gateway, in that case, there will be a delay that will be at the receiver's end, right? You will receive, your pages will not open, your videos will not get downloaded. So a lot of these things happen. So in that case, what do we do is that, look here. So this round one is the enterprise internet or the institutional router. Sorry, enterprise link to the ISP or the institutional router, and this is connected with different switches. Okay, that is Ethernet switch. So you might see in your hostels where the network room is there, you can see that there are big devices from where you get different Ethernet cables coming out, right? So you will have the Ethernet switch there. Okay, so what is the job of the Ethernet switch? The Ethernet switch basically connects all of these devices to the router. Okay, so the LAN cable that is there in your hostel room, essentially you are getting that connection from this Ethernet switch which is there somewhere in your hostel. Okay, so and in each room from this switch there is connection that is going to each room. Okay, and all the data that is coming out, or the data that needs to be going to your systems, whatever the data upstream or downstream, that data is basically being sent to this particular institutional router. Okay, now excuse me. Now there is the concept of web servers or institutional mail server. So what we have in our institute, we also have a web server in our institute, we also have a mail server. And why do we have that? Because we want, of course, we want fast access, right? Fast access to the internet. So if you have studied computer organization in the last semester, I suppose. So in that case, you had the concept of caches. Now, the web server also acts as a cache, okay, for our institute system or any kind of enterprise network system. So what happens here is that all the all the web pages that are mostly searched for or requested for from the users, and all the kinds of videos that are requested for mostly, so they are stored in this web server. Okay, so whenever there is a user that is asking for this kind of information, it will be faster and easier to send it directly through the web server rather than going through this entire link. That is, every time, suppose for example, every time you want to open Facebook, you don't have to wait a long time until your data basically contents with all of the data that is getting transmitted gets to the institutional router, gets further beyond to the ISP, and then gets back the data that is related to just opening the Facebook page, home page. So instead, what can be done is that if the content of that web page is saved here, because so many people are opening Facebook, so instead this information or this data can be simply sent out through this web server to your device rather than going all the way to the ISP. So I hope this part is clear. Now, when we are talking about Ethernet connections, the transmission rate that it provides is around 100 Mbps to 10 Gbps. Okay, whereas as I've already mentioned, your Wi-Fi access points that you use in your offices or homes, etc. So they will provide around either 1154 to or 450 Mbps of data rate, depending upon what is the standard that is being used in your device. Now, this is something that is quite interesting, and that is a data center network. Okay? So, data center is basically, you know what it is. It is a hub of a large amount of data that is being stored, right? And there has to be communication with these data center networks, constant power, constant, you know, um, you have to basically keep these storages very carefully. Constant monitoring has to be there, right? You have already studied different architectures that are used in order to store these kinds of large amounts of data. So how the communication part is working, that is about the data center network. So what happens here? So you need a very high bandwidth link that is around up to 100 Gbps. This is required because that will connect thousands of servers together. Okay, and that is basically what will constitute of this data center network. Okay? Large number of servers are there together. They are connected to the internet as well as they are connected to each other, and they need very high bandwidth links so that the access delay that you are getting at the end as a user, that becomes least, okay, or lower as much as possible. Okay. Now we have studied until how to access the network. Okay, that is what is the medium and what is the technology that can be used to access the network. Okay, now we are going a little bit deeper. That is how the host will send its information or any information to the rest of the internet. Okay, so if you remember in the last class, I had mentioned something about packets, right? So packet is basically a unit of data um, that is being transferred, right? So you cannot always send just one bit kind of data. That is cumbersome, right? So you just send a set of bytes of data and call it as packets, which is just a chunk of data. Okay? So what does the host sending function do? It takes the application message and it breaks it into smaller chunks known as packets. Okay? So, for example, the length of these packets is L bits. That is what we are using in this example. Okay, and the link, the communication link from your system to the switch that is here, that is providing a transmission rate of R. Now, this transmission rate or R is also known as the capacity that the link is basically providing, or the bandwidth that the link is providing. Now, what is the delay that will be received at the receiver's end to receive this L byte of or L bit of packet? Okay, so that means time needed to transmit the L bit packet into the link. Okay, that is known as the transmission delay. Okay, and that is given by L by R. Right, so that will give you the time that will be required to transmit the packet to the link. Okay, so this is packet 1, this is packet 2. So the time that will be required to transmit all the bits of this one packet number 1 onto this link, okay, which is having a bandwidth of R, that is known as the transmission delay, and that is given by L by R. Okay. So let's get to what are the different kinds of mediums, okay, physical mediums through which data can propagate. Okay, so we know that data can propagate. I mean, the data that we are sending is basically bits of data, but we are sending it as signals. Now, there are physical links which are there between devices, which will basically connect the transmitter and the receiver. So that is one host to another host. That's the communication link. If you have a wired link, a physical link, that is what lies between the transmitter and the receiver. Now, these physical links are divided into two categories. One is guided medium and another is unguided medium. Okay? So, what is guided media? The plural is media. So, the guided media is nothing but, you know, the medium which is basically a tangible medium, right? That means a wired kind of a medium. Okay, so it is the signal that propagates in a solid media. It can be either a copper wire cable, a fiber cable, a coaxial cable, or it can also be an optical wire, optical fiber. The other one is the unguided media, where signals propagate freely. And where are they freely propagating? Over the air, right? That's the medium there. Okay, so these are basically, for example, you have the radio signals, right? So they are basically following an unguided media for their propagation. So first we'll talk about what are the different kinds of guided medium. Okay, so first type of wire is twisted pair copper wire cables. So what we have here is there are two insulated copper wires are basically twisted with each other. Okay, and then they are used for communication. But uh, can you tell me why two insulated copper wires are twisted with each other? Is there any answer for this question? Can someone tell me?
So that the magnetic induction doesn't happen.
Can you name yourself, please?
Lakshmi Narayana.
Yes. So can you repeat your answer?
Like if they are not twisted, if they are parallel, then we have magnetic induction that happens in there that can affect other devices. So
Exactly.
to nullify,
Yes. So to avoid, to minimize the amount of magnetic induction that will be there, for that reason we use twisted copper wire cables. Okay, twisted and insulated copper wire cables. Okay, so they are again divided into categories. So we use in general in our Ethernet cables that we use in our LAN connections. We use either the category 5 Ethernet cable or the category 6 Ethernet cable. Category 5 can provide up to 100 Mbps or 1 Gbps connection or transmission rate, sorry, and category 6 can provide up to 10 Gbps rate. Okay. Now let's get to coaxial cable. Okay. So coaxial cable basically has two concentric copper wire conductors. Okay, and they are separated with the help of insulations in between, of course. Okay, it provides bidirectional communication. It is in general used for broadband communications because it helps to provide multiple frequency channels. Okay, as we had talked about, like in your cable connections, in your broadband connections, in those you need different frequencies. Okay, you need signals at different frequencies to be transmitted. Okay, so for those kind of signals, this coaxial cable is used, and it provides around 100 Mbps of data rate per channel. The next one is your fiber optic cable. So I think it needs no introduction. All of you have studied in your basic physics courses, right? What is a fiber optic cable and why do we use it? So can I hear something from all of you as to why fiber optic cables are used?
They are a lot faster than the copper cables.
Can you please name yourself?
Saket Kumar.
Sasaki, can you please be a little bit louder? I couldn't hear you.
I was telling that because they are a lot faster than copper cables.
Why they are faster?
Because they
Just
use
fast.
light. Because they use light to propagate the information. Like it depends,
Yes,
it works on the principle of total internal reflection.
exactly. So they use light pulses for communication, and they use total internal reflection that will definitely reduce the amount of the data that just is lost in signal propagation, right? So that is why fiber optic cables are used. Okay, it provides very high speed operations from your transmitter to the receiver. It's around, it can give up to tens to hundreds of Gbps of data rate. Okay, and of course there is low error rate. All right, now we are getting into wireless radio. Okay, so how does wireless connection work? Okay, so signals in wireless communication, they are sent over the electromagnetic spectrum. Okay, and in this electromagnetic spectrum there are various bands which are used for different types of communication. Each band provides a certain frequency, a certain amplitude. Now depending upon what is the kind of application you want to serve, that particular band is used for communication. So suppose there is a kind of communication where you want that the transmission should happen for a larger distance. The delay does not matter, or the rate at which you are getting the data, that may not matter that much, but it should provide communication to a very large area. Okay, so in that case you would go for the frequency, the band, sorry, the band where the frequency is a little less, the amplitude is a little higher, right? Whereas in case of the other way round, that is, if you want that, you want faster communication, then you go to high frequency bands, right? So in wireless communication, of course you do not need your wire here. In general, what we do is we broadcast information, right? That means from a particular transmitter, you can actually, no, I wouldn't say that in general you broadcast information. I would say that you can actually have the feature of broadcasting information. That means one particular transmitter can transmit its information to several users which are there, to several receivers which are there in its transmission range at the same time. Okay, so it's like shouting from the top of your house, something like whatever you want to shout from the top of your house, so that everybody around your in your neighborhood can hear you. That's what broadcast is, right? And of course, it provides half duplex communication. That is, at a time, the I think you all know what is half duplex communication. That is, at a time, only at one side the communication will go ahead. But of course, as we know that when we are talking about transmission over the medium, that which is air, so in that case there will be several other problems that will also come into picture. Okay, so what are those effects that the environment puts when we are trying to propagate signals over wireless medium? So you will have reflection. Okay, reflection is one issue. Then there will be obstruction by objects, and of course there will be interference from other signals, which will basically act as noise to your current signal. Okay, so that means if you are shouting and on the top of your house, and somebody else is also shouting at the top of their house, for you your signal is important, so you will hear that other person's shouting as noise, and the one who's at the receiver's end, he will basically hear both of your noises or both of your shouting, and it will be very difficult for them to understand that what each one of you is saying, right? So that's what is basically interference and noise. So there are different radio link types that are used for wireless communication. So first one, as we all are very much aware of, is Wi-Fi or wireless LAN. LAN is local area network that is used for very small kind of networks. Wireless LAN is nothing but a Wi-Fi connection or a wireless connection that is used to provide connection to a very small area, that is either an office or a home, etc. Okay. So it provides up to a maximum of 100 Mbps of data rate or transmission rate, and its transmission range is very small, around some. It's written as tens of meters, but yeah, nowadays with different standards that Wi-Fi has come up, it will go up to 50 meters. Okay, 50 to 100 meters also it can go, depending upon what is the Wi-Fi standard that is being used. Now, as we have studied that, one we have studied is local area network. Now we are going to talk about wide area networks. Okay, that means a bigger area, a village or a town or a city, etc. So that can be provided with the help of cellular communication, which is basically your 4G or 5G network. It can provide up to 10 Mbps, more than 10 Mbps of data rate, and the transmission range is up to 10 kilometers. Another another wireless communication technology is basically Bluetooth, right? So Bluetooth is for very short distances. Okay, very short distances Bluetooth is used, and one of the very important features of Bluetooth is that Bluetooth is um, limited by the number of devices that can actually get connected. Okay? So Bluetooth can actually have, I think, 6 or 8 devices. I just have to check it once again. I think 6 or 8 devices at the max. It cannot support more than that. Okay, and it's a very peculiar kind of very interesting, actually it's a very interesting kind of a technology that is used. Okay, whatever is used in Bluetooth, the way the different devices they connect, that is basically a master slave kind of technology that is used. Okay, so anyways, those are different concepts that you will study probably later on in your courses. uh, as of now, Bluetooth is used for communication between very short distances, and it provides limited data rates. The next type of communication over wireless links is terrestrial microwave connections. Okay, these are basically point-to-point connections. So suppose you have one antenna at one point in Earth, and then you are basically communicating with another point, and it gives around 45 Mbps of data rate. The other one is, of course, satellite communication. So as we all know that we have our satellites, and from there you can actually have some repeaters, some end stations, which basically will help to receive and transmit data to the satellites, and then communication can happen. They provide large data rates up to 45 Mbps per channel. Okay, so that's a very high data rate, and they provide very less delay. That is 200. They provide not less delay. They provide quite a bit of delay, which is the end-to-end delay because of the distance that needs to be covered. Right, so that is around 270 milliseconds. All right, so fine. I think I don't have time now. It's already 2:56, so I will not start with the next part of this course. So that is packet switching and circuit switching. So that we will start in the next class. If anybody has any questions, you can ask me now.